In this lesson, we're going to just look at an example of how we go from a sinusoid graph to an equation. Now, as we mentioned in class previously, every sinusoid can be written as either a sine or a cosine function, and there's going to be infinitely many sine or cosine equations that could represent this graph. So we just have to come up with one of the feasible ones. So I'm going to start by just kind of organizing my work. I'm going to write my sine function and my work that I'm going to do to get that sine function in this area. And I'm going to write my cosine function and the work that I'm doing to get my cosine function over in this area. The first thing I'd want to do is to identify my midline. Again, the midline is the line that kind of cuts the graph in half, the horizontal line that cuts it in half. So that looks like here at y equals 1. The nice part about this is the midline is y equals k. So that tells me my value for k right away. And regardless if you're writing a sine or a cosine, that value for k is going to be the same. The next thing I'm going to do is figure out my amplitude. If you remember from last time, the amplitude is the distance from like a maximum or minimum back to the midline. So the max happens up here at 4, and the midline happens here at 1, so that distance must have been 3. So that's my amplitude. And that amplitude is going to be the same whether we're talking about a sine or a cosine function. Now, keep in mind that what I found is the absolute value of a is equal to 3. I haven't found the value for a yet. I don't know if a is going to be positive or negative. That'll depend a little bit on how I'm going to find my h. So right now I'm just going to leave it as the absolute value of 3. And it very well could be a positive for sine and a negative for cosine or vice versa. Or it could be the same, depending on the points that we use to find h. So the next thing I'm going to do, I'm going to leave that hanging for right now, is I'm going to go and find my c. So the c was related to the period. So to figure out the period, I'm going to go from either max to max or min to min. I'm just going to look at how far it is horizontally. So this distance is 1 period, going from min to min or max to max. I chose to do min to min because there's a little bit more room down here to work. But my first minimum happens at negative 1.25 pi. My second one at negative 0.25 pi. So to go from negative 1.25 to negative 0.25, I went 1 pi. Okay. And I remember that a period is 2 pi times c. So that tells me the absolute value of c is 1/2, just by dividing both sides by 2 pi. And that is going to be the same regardless of whether we're working with a sine or a cosine. So we're almost there. We still need to determine whether these values for a and c need to be positive or negative. And then we still need to find a value for h. Now, the c, we can always just assume to be positive. Now, it's possible to write a correct answer where the c is negative, but it's never going to be less work to use a negative c, and it could often be more work to use a negative c. So I always just assume my c is positive because I can write an answer, a correct answer with a positive c every single time. So the c I'm just going to always assume is positive. Next, I'm going to find my value for h. And this is by far the trickiest part of this. So what I'm going to do for this is I'm going to recall the key points from my sine and cosine function that we used to graph, that we talked about the other day. And for sine, I'm going to find the key point that has an x-coordinate of 0. So on the parent function, that point was 0, 0. And for cosine, the point on my parent function was 0, 1. For problems like this is always the points that I'll use for my parent functions. Now, if I went back and I looked at my parent function, this point 0, 0 was a midline point. And on cosine, this function, or this point 0, 1 was a maximum. Now, important to determining the value for A in my sine graph, I have to know that preceding that midline point in my parent function was a minimum, and following it was a maximum. That will always be the same for all cosine, or for all sine functions, because if you remember back to yesterday, if we looked at the graph of sine like this was a part of it, so we had the minimum, there's our point 0, 0, and then a maximum. So that's what the min, ML, and max are just representing as the order in which those are happening. And this is always going to be the same every time we use this point for a sine function. And this would always be the same every time we use that point for a cosine function. What I'm going to do now is I'm going to go to my transformed function up above, and I'm going to locate another midline point. Now, it doesn't matter which of those midline points I pick. Like we have like a whole heap of them to pick from. It doesn't matter which one I choose. Let's say for the sake of argument, I pick this one, which is at 0.5 pi and 1. I'm going to write 0.5 pi is just pi over 2. Okay? And very important, next, I'm going to go back and look at that point. Preceding that point was a maximum, and following that point was a minimum. So I'm going to record that information. So I went max, midline, and then min. Okay, now I have all my information that I need to figure out my value for H and my sine for A. Let me show you how to do this. So notice that here, the order is opposite. In the parent function, it's minimum, midline, maximum. In my transform function with the point I've chosen, it's maximum, midline, minimum. Since those are opposites, that tells me that the A needs to be negative. If they were the same, the A would have to be positive. And then here, what this tells me is that H is pi over 2. Let me show you why. So you remember that when we graphed, we had this transformation map, right? So what this says is this is how I take a point from the parent function and turn it into a point in the transformed function. So I know that Cx from the parent function plus h should equal x from the transformed function. So RC was 1/2. The x from the parent function is 0 plus h should equal the x from the transformed function, which was pi over 2. 1/2 times 0 is 0. 0 plus h is just h. So h is just that x from the transformed function. If you had had to choose a point from the parent function whose x-coordinate is not 0, that algebra becomes a little bit more involved because now c times x isn't 0, so you can't shortcut straight to getting your h. But as long as you're picking a point from the parent function whose x-coordinate is 0, we can just shortcut straight to the h. So now, for sine, I have everything that I need. I have my a, I have my c, I have my h, and I have my k. My a was negative 3. My c was 1/2, so 1 over c is going to be the reciprocal. That's just 2. I have x minus h plus k. And the k in this case was, what was it? 1. So there's my answer, or an answer. There's infinitely many. Depending on which point you chose, here you could have gotten a different answer with a different h, but still correct. Okay, let's write this for cosine, or figure this out for cosine. For cosine, since the parent function was a maximum, I can pick any of the extreme points. So I could pick any of these minimums, or minima, I guess, or any of these maxima. Any of them would be fine. For the sake of argument, I'm going to pick this one, which is at 0.25 pi and 4. Instead of writing as 0.25 pi, I'm going to write it as pi over 4. And this was a maximum. Since these were the same, what that tells me is the a is positive. So I know that my a is 3. And since this is 0, I know that my h is just pi over 4. Again, I'm using the same kind of algebra that I would have used in the previous one, which you can do by hand if you want, or you can just remember that when the parent function point you're using has a 0 for the x-coordinate, the transform point that you're using is the x-coordinate is just going to be h. And that's everything we need, right? So the cosine one was really not much more difficult, or any harder or easier per se. But I did a little less explanation because I did a lot more explaining on the sine one because it's still kind of the same process. And there we go. So good luck on worksheet 3 and a couple of homework problems, and we'll see you guys next time. Have a good day.